Okay, so we're going to start with just kind of a quick sort of definition for what hypothesis testing is. Okay, so what is hypothesis testing? It is a 5-step process. Okay, we're not going to do all the steps today. We'll probably only get through the first 2 steps of the 5. Okay, and then we'll do the other 3 on Wednesday. All right, but there are 5 steps in the process. And what it does is it gives us a way to evaluate a claim that someone makes about the population. Okay, so I would write those 2 little statements down, and then we're going to sort of talk through just an example. Okay, so I'm going to put an example up. I don't think you need to write the example down. Okay, let's just sort of, we'll have plenty to write later, but let's just look at this. All right, so this is a claim. Okay, so it says, the University System of Georgia states that the average age of college graduates is 23.1 years. So that's what they're claiming to be true. And then our job is going to be able to come in and say, yeah, I agree with that, or no, I don't. Okay, so that's sort of where we're heading with this. We're going to evaluate that claim, decide whether we agree or disagree. All right, so let's talk a little bit about how we would agree or disagree with that claim. Jason, start the first 2. Okay, so I'm going to take that same statement and I'm just going to move it to another slide so we can think about it a minute. All right, so University System of Georgia states that average age of college graduates is 23.1 years. All right, so again, don't write, let's just talk. All right, so you decide to do your own research. All right, you're going to try to decide whether you agree or you disagree with that particular statement. All right, so what are you going to do? So you're going to pick a sample of college graduates, because you wouldn't ask every college graduate in the United States because that would be too big, right? So you might say, okay, we'll pick 100 students. And you're going to go to those 100 students and you're going to ask them how old they are after they've graduated. All right, so let's say that you calculate the average for these 100 college graduates, you add up all your ages, you divide by 100, you get 23.2. So University System of Georgia said the average was 23.1. You did your own research. You came up with 23.2. Okay. So do you tell the university system that they're wrong? No. Because you basically got the same thing, right? I mean, you're a little bit different, but very small amount different, and maybe that's just rounding, or maybe your sample wasn't great, or whatever, but that's not enough of a difference for you to say, hey, you did something wrong. Right, do we all agree with that? Okay. But if you had done your average, and instead of 23.2, maybe you got 20.3, then what? Then maybe you go to them and you say, hey, I don't agree with what you came up with. Like, let's double check that. I don't think it's right. You know, that kind of thing. Right? Because when you compare 23.2 to what they got, there's a bigger difference. Does that make sense as a concept? So you take their claim, you do your own research, you kind of compare your number to theirs, and you make a conclusion. That's the gist of hypothesis testing. All right, so let's talk about step 1 in this process. Okay, so the first thing that we're going to look at today, and you do want to write this part down. All right, so step 1 is that we're going to write hypotheses for problems. And you are always going to write 2. Okay, so every time you work a problem, you're going to be writing 2 statements that are hypotheses. So the first one, we're going to call the null hypothesis. And we're going to abbreviate it H, and then this subscript of 0. Okay, we'll call it H sub 0. And that hypothesis says that there's no significant difference between the 2 numbers. So that's what we saw in our example. I'm going to go back here. Okay, so that's what we saw in our example here. University system said 23.1, we said 23.2. You guys told me that that was no real difference between those 2 numbers, right? Okay, so that is the null hypothesis. Null hypothesis says there is no difference between the 2 values. It's like comparing the 23.2 to the 23.1. You basically say, who cares? They're basically the same number. All right. The other hypothesis is called the alternate hypothesis. This one we're going to use H1 as a symbol. And that says there is a difference between the 2 values. So that's the other scenario. That was the one where we said, okay, university system said 23.2. We came up with, I think I said 20.7. And you guys said, yeah, that's a big difference. We would say that they were wrong. Okay. So there is a difference between the 2 values. That's the alternate hypothesis. Okay. So we're going to take a couple of examples and we're going to work on writing those 2 statements for each of those examples. So probably what I would say too, because we're going to kind of go back and put some other stuff on it, is maybe grab, if you've got plenty of paper, grab a clean sheet of paper and write example 1. Okay. And we'll kind of do our 3 examples on separate paper. It'll help us have room to write everything we need to write in just a few minutes. Okay, so I'm going to copy this one down for example 1. Or at the very minimum, take a picture. Okay, so it says a chemist invents a new additive that he hopes will increase the life of a car battery. Average life of a car battery is 36 months. Okay. So remember that the null hypothesis, which is where I'm going to start here. The null hypothesis says that there's really no difference. Okay, so what that means in our case is that he puts that additive into the car battery and nothing changes. So that means, and the way I'm going to write this, I'm going to use this symbol, which I don't think we've seen that symbol before. That is the symbol for the mean of the population. Let's make that note just so you know what that is. So we talked about mean, but when we talked about it being in reference to a sample. When we do hypothesis testing, we're kind of talking about in general, we expect this to happen. So we're talking about the big group, and we use a different symbol. So he puts that additive into the car battery, and the average stays the same. The average is still equal to 36. Right? That's my null hypothesis. Remember, the null hypothesis says nothing changes. We get the same thing. So the average with the additive is still 36, just like it was before. All right, for the other hypothesis, this is usually the one that represents what he wants to have happen. So we kind of look for keywords in the problem. He wants the additive to increase the life of the car battery. So he wants to put that additive into the battery and have the average lifetime get bigger than 36, right? So bigger than 36 would be a greater than. So those are kind of the two options that can happen. I mean, I guess technically it could make it last shorter, but we really don't want that to happen at all. So it either basically stays the same and it doesn't do anything, or it increases the life of the battery, making it greater than 36. Okay, and those are my two hypotheses. Does that make sense? All right, so we're going to come back and work on this one in just a minute a little bit more. All right, so I'm going to go to another page and let's write down example 2. Okay, so we've got some room on example 1 and we're coming back to it. All right, so example 2 says that a contractor invents a new type of insulation, which he thinks will lower home heating bills. Average home heating bill is $140. Okay, so remember that the null hypothesis says there's no difference. So he puts the insulation into a house and there's no difference. Which means what about the average? It's going to stay the same. So it's going to stay equal to 140. Right? No difference. Don't change anything. You're still looking at a home heating bill of 140. All right. The other one reflects what he's hoping is going to happen. So he wants this insulation to lower the home heating bills, right? So he wants the average to be what? Less than good, 140. All right, does that make sense to everybody? Okay, at home with the question? All right, let's do one more, and then we're going to kind of come back and fill in some stuff on these. All right, so one more piece of paper. I've moved to new sheet. All right, this is example 3. So this is sort of the third way that this thing can set up. All right, so this one says a psychologist feels that playing music during a test will change the results of the test. He's not sure whether the grades are going to be higher or lower. In the past, the average of the scores was 73. Okay, so again, the null hypothesis, the first one basically says nothing changes. So he plays the music during the test. Test scores don't really change. So what am I going to write? That the average is nothing changes. What am I going to write?
73.
Equal to 73, right? Stays the same. Test average was 73. I now play the music. Nothing changed. It's still 73. All right. So let's look at the one he is thinking about. He wants to see if it changes the results. Now, I have to be kind of careful here because of this thing that says he doesn't know if it's going to be higher or lower. So I've got to come up with some sort of statement that reflects both options. So, I mean, if I were to write it this way, then I'm saying he's only interested in it being higher. All right, so that's not going to work. And if I write it this way, I'm saying he's only interested in it being lower. And that's not going to work either. So my other option here is to write it this way. So I basically say it's not equal to 73. It might be more, it might be less. Okay, and that sort of includes both of those options. All right, so the 3 examples that we have just done are the only 3 scenarios that you'll see in terms of setting up your hypotheses. So I want you to look at them. The H0 always has what? What's the same in all 3 examples? The equal to. Okay, so the H0 has always got an equal to in it, regardless of what the problem looks like. And then the H1 is either has a less than or greater than or not equal to. And those are the three options that you can have. All right, anybody have a question? Okay, so that's step one, is to get those two statements written. All right, so let's look at step two. Like I said, we're coming back to these three examples, and we're going to add step two to those three examples. All right, so step two is finding what we call a critical value. All right, so I'm going to give you just a couple of things real quick, and we'll come back and add a little bit more in a minute. Okay, so for each of these problems, we're going to end up drawing one of those curves that we looked at in the last chapter, okay, the standard normal distribution curve. And we're going to shade part of that curve. And so this critical value is going to separate the shaded part from the unshaded. And we're going to shade the part of the curve where there is a significant difference. Okay, so I'm going to let you jot those two statements down, and we're going to go back to our examples and look. All right, so let's go back to the first example. Okay, so what I'm going to do is I'm going to draw a curve. Remember, 0 sits in the middle of that curve. Okay, so go ahead on your first example, draw yourself a curve. Remember, the mean is in the middle. So z-score is 0, but regular number, it tells me the average is 36. So I'm just going to kind of make a note that this is 36. All right. So he's hoping that this additive that he puts in a car battery is going to make the battery go longer, right? Increase. Okay, so let's say, let me just give you some examples. Let's say he puts it in there and the battery goes to 37 months, which is going to be on the right side of 36, right? Because it's bigger. Okay, so is that enough of a difference for you to go buy this additive? All right, I mean, let's say that the additive costs $75. You're going to go buy it so that your battery will last one more month. What do you think? You go buy it or not? Yeah, no, I'm not. I mean, not for 1 month, right? Yeah. Okay, what if he claims it lasts 38 months? I'm still not buying, right? Not at $75, not for 2 months, okay? But let's say that he claims that it makes my battery last 75 months. Then would you go buy it? Yeah, okay. So remember, you're trying to shade the part of the curve where there is a significant difference. So we're saying at 37 and 38, we don't really care. But if you go up to 75, we're saying, yeah, that's probably a big enough lifespan increase for me to go by. So would you agree that somewhere on this right-hand side, there's like a dividing line where if the lifespan of the battery is over here, I'm saying I don't care. Not enough for me to worry about. But if the lifespan of the battery is on this side of the line, I'm saying I'm going by that. There's some dividing line for me, right? I mean, 37, 38, I don't care, but at 75, I do. So there's some point where I stop saying I don't care and I start moving to the store, right? Okay. Remember, we're shading where there's a significant difference. So I'm going to shade everything past that dividing line.
So you always want to shade furthest away from the beam.
Yes, because that's going to show a significant difference. Okay. All right, and then remember that your critical number, clean this up a little bit, your critical number is going to be the z-score that separates the shaded from the unshaded. Okay. So we're going to have a z value right here that we're going to find in just a couple of minutes. All right. Also sort of note the correlation between the H1 statement and how you shade it. Okay, the H1 has what symbol in it? What is this symbol right here? Greater than. You shade it on the right. It's not really a coincidence, okay? So you can use that as well to sort of help you decide where to shade. Okay, so let's go to example 2. All right, draw a curve. Okay. Average is sitting in the middle. Z-score of 0, but regular number of 140. Okay, so remember that he wants it to lower the home heating bills. So he puts this insulation in somebody's house, and their heating bill drops to $139. Are you going to change the insulation in your house to save $1 a month? No. What if your heating bill drops to $138? You're going to save $2 a month and change? No. What if your heating bill dropped to $25? And would you be putting new insulation in your house? Yes. Okay. So again, somewhere on that side, there's this dividing line between the numbers like 139 and 138, 137, where we don't care, and the numbers like 25, where we're buying new insulation, right? We're shading significant difference. So we're shading everything on this left tail. Z-score separates shaded from unshaded. That's the critical value. We're going to find it in just a minute. All right, again, note the symbol in the H1 is less than, we shaded on the left. Okay, not a coincidence. All right, last one, example 3. All right, so let's draw our curve here. Mean in the middle. Mean is 0 as a z-score, but 73 as a regular number. Does anybody have a feel for how this one is going to get shaded? Keeping in mind that he doesn't really care if it makes it higher or lower.
Yes, we shade significant on both sides.
Yes, so we shade significant on both sides. So you're going to have this section on the right-hand side. This would be significantly more. This would be like the numbers like 100, 120. This would be the significant more values. And then you're also going to have a section on the left-hand side. And this would be significantly less. This would be like the 20s and the 30s. Okay, significantly less than the 73. All right, and that two-tailed shading on both sides goes with the not equal to. So anytime you have a problem that has a not equal to, you're going to end up shading on both sides of the curve. Okay, so you guys good there? Okay, just a quick recap. So if your H1 has that symbol, you shade on which side? That symbol is what? That's the left. Remember, like you do it with your finger and it looks sort of like an L, so that's the less than, so you're going to shade on the left, right? Okay, so that one would look like that. All right, if it has that one, you're going to shade how? On the right side. All right? And if it has the not equal to, both sides. Okay, and that doesn't change. Like that's standard from one problem to the next. So look at that H1, see how that shading is supposed to be based on that symbol. All right, anybody with a question before we move on? Okay, so the only other thing we're going to do today is we're going to actually find the z-scores. All right, so you need your table. Do you guys have it by any chance? Those of you at home, if you can grab a copy of your table that we used in the last chapter, we're going to use that table to find these z-scores. All right, so let me go back to the notes part just for a second. Okay, so let's add just a couple of things here. All right, so let's add these two statements. Okay, so to find that critical value, we're going to base it on what's called a level of significance, which they're going to use an alpha to stand for that, like the little fish symbol. Okay, they're going to tell you that in the book or on Connect Math or wherever you're working on a problem, they would give you that alpha value. And what it is the area of the shaded region of the curve. So it's the thing that you need in order to actually use your table to find your z-score. Okay, so let's go back one more time to example 1. So we're going to now find that z value for that problem. All right, so again, they're going to give you an alpha value. So I'm just going to write something over here so we have something to use. So let's suppose that they tell me that the alpha value is 0.01. Okay, and again, they're going to give you that. So when they give you that, remember that they're giving you the area of the shaded part of the curve. So they essentially are telling you that this part of the curve is 0.01. And your job is to find the z value. Now, this isn't new because we did this in the last chapter, okay? So remember that for your table that you're about to use, that the only way you can use the table is if you have the area from 0 to z, right? Matches that picture at the bottom of the table. So what do I need to do in order to find how much it is from 0 to z? You guys remember how you find that?
Subtract 1.5.
Subtract from 0.5, right? So I'm going to do 0.5 minus 0.01. And that gives me 0.49. And that's that part. Okay, and then I'm going to go to my table. Right, and I'm going to look for the closest thing to 0.4900. So the best I can find is 4901. Do you guys agree with that? That's the closest you can get to it. And so now I'm going to read off that z-score that goes with it. What is it, Jason? 2.33. Okay, so 2.33. It's going to be that z. That's going to be my critical value. All right, okay there? All right, so let's look at example 2. Do the same thing. All right, so let's say on this one that the book or Connect Math tells you to use 0.10 as your alpha value. So again, that's the area of the shaded part. So what do you need to do first?
Subtract the 0.5 from 10.
Subtract the 0.5 and the 0.10. That's going to give you this piece, which is what you need in order to use the table, right?
Mhm.
Then you're going to find the closest thing to it. In the middle of the table, closest thing to it.
3997.
Yeah, so I was thinking 3917. And that z-score that goes with 3997,
1.28.
1.28. We're going to put a negative on it because it's on the left. So that's my critical value there. Okay, everybody okay with this too? All right, so the third one is a little bit different because the area is split in two parts. So let's say that I give you an alpha value of 0.05. And 0.05 is the total area that is shaded. So not the area of each one. Okay. So because I have two parts, I've got to take that total and divide it in half so that I know the area for each part. So 0.05 divided by 2 is going to tell me that this part is 0.025. And this part is also 0.025. Okay, so again, a little bit different because the area is split into two pieces. You've got to cut that alpha value in half first. From that point, it proceeds just like the other two. Okay, we need to find this part so that we can use our table. So we're going to subtract one of the tail values from point. That should give you 4750. And then we go to the table and we look up 4750. I think that one is actually in there. Corresponds to a z-score of what?
196.
196. 1.96. And it'll be the same on both sides, but we'll have one that's negative and one that's positive. All right, so that's it for step 2. Does anybody have a question?